that cause trouble. So, of course, I review it. Okay, so that's what a polynomial is. The word is from Greek. It's many numbers. Poly meaning many. Nominal is from the Greek word for numbers. So a polynomial, I'll write a polynomial that has all of these three things, and I will keep the color coding going. That is a polynomial. The green thing is a coefficient. The red thing's a variable. The blue thing's a constant. A polynomial has one, two, or all three of those things involved. Now, there are some weird rules about polynomials. Okay? We're not going to get into them right now. We're just going to get into the basics. We'll talk about the weird rules about them a little later. All right? Now, the first thing you all need to know is when I write that, there's no answer. Okay? Because there's no equal sign. The only thing you can do with polynomials is change the way they look through simplification. Okay? There is no answer until there's an equal sign. That is why I use the word expression. Everybody cool? Yeah? Okay. So, there's three types that have special names. You all already know this from the 9th grade, I hope. A monomial is a single term polynomial. I don't want to say that. A single term expression. And since a monomial is a polynomial can have a combination of these things. All right? For example, 5q squared is a monomial. It's got a combination of coefficients and variables. Everybody cool? Okay. 8 is a monomial. It's just a constant. M, just a variable. Everybody cool? Okay. Now, the way you can tell it's a monomial is... Nope, there's no equal sign. The way you can tell it is a monomial is the components are joined by multiplication. Everybody cool? So if I did this, 3 A, B, C, D, E, F. that is still a monomial. Everybody understand? Because it is all joined by multiplication. Even if I put a squared in there, it's still all multiplying. Everybody cool? All right. Being the intelligent young people that you are, a binomial is a two-term expression. Well, so if one term is any combination of variables, constants, or coefficients connected by multiplying, how do I get to the second term? I use addition or subtraction. Why do I not use division? What's division really? It's multiplying by fractions, yes? So division doesn't get me a new term. Everybody cool? So it's a two-term expression like a bicycle. Binomial, bicycle. Two-term expression. Three. No, wait, those are what I'm using. Can I ditch the colors now? Thank you. 3x squared plus 5y squared. Binomial. 3 is connected to the x by multiplication. X is connected to a second x by multiplication. So it's one term. Plus 5 is connected to the y by multiplication. Y is connected to a second y by multiplication. Second term. Right? Obviously, what's a trinomial? A three-term expression. 4x squared plus 7x minus 3. Easy peasy lemon squeezy, right? After that, they don't have fun names. After that, they're just a polynomial. Okay? We don't call them a quadrinomial, quintinomial, sextinomial, septinomial, octinomial, nonomial, decanomial. We don't. They're just polynomials. Okay? All right. Now, the next thing. This term, the degree of polynomials, it becomes important later on, but for our purposes, we use the degree of polynomial to put polynomials into an agreed upon order. So if you have a really long polynomial with all kinds of x's and y's and cubes and stuff, there's a way that we like to write it. All right? And that is written right here. Descending degree and or descending exponents of x. Now, what if I don't have any x's? This means alphabetical. And I'm going to show you what I mean. Alphabetical. I ran out of room. So here's what I mean. First, we talk about the degree. The degree is the highest sum. Please underline sum of exponents in any one term. Okay? So, we'll just do a couple to show you what I mean. 4x. What degree do you think that is? 1. Because the exponent, in any one term of exponents with variables. Sorry. Forgot that part. So this is a first degree polynomial because the exponent x has the variable x has an exponent of 1. Good? Okay. What would this one be? That would be a second degree polynomial. Everybody cool? Okay. What would this one be? A third degree polynomial, because the y has a 1. Is everybody cool? Okay. And lastly, what would this one be? No, wait. Wait. Highest sum of exponents in any one term. So this is still a third degree polynomial. Okay? Mr. Kenny, what maybe? Oh, yeah. Everybody cool? So this guy is still a third degree. Yes. Now, like I say, it becomes important later on, but in grade 10, the only thing we care about is writing it in, firstly, descending degree, and then we look at the exponents of x, or the first alphabetical letter. So what's the biggest degree here? 4x squared y, right? Okay, so we know this guy would be written, some teachers and some people, I say agreed upon, but it's not totally. Because some people will say the highest degree has to go first. So some people will say it's 4x squared y plus 3x squared plus 3 plus 4x. Some people will say that is right. Everybody with me? Because that's the highest degree. But other people will say, no. There's no or here. It's alphabetical and highest degree. So what's the first alphabetical letter there? Is it X or XY? If you were writing these in alphabetical order, you would put the X first, right? So this would be 3x squared. Now I'm done with all the x squareds. Then I've got a 4x squared y. Then I've got a 4x because I'm dealing with all the x's first. Then I start in on the y's. Do you think I care? No, not even a little. Now I have just said I don't care, not even a little. Who would like to guess how many times one of you is going to ask me, what order should I write that in over the next couple of days? At least 5 or 6 times. So I'm going to say this again. I do not care. You write polynomials anyway you want. Okay? And even though I've done that, somebody will still forget and say, is it all right if I write it in the other order? Yes, it's all right if you write it in that other order. Okay? Now, unfortunately for me, I am given a variety of things that I am forced to teach you. Unfortunately for you, I am forced to evaluate your knowledge on those things, whether I think they are useful or not. I know that maybe you have already done what I am about to do, but I do not care, because for the 10th grade, I am supposed to teach this to you, so I am going to. For some strange reason, the ability to do math with numbers is not good enough for the British Columbia government. You also need to be able to do math with pictures, because apparently we're cave people, and we do all our math with pictures. I don't make these rules, but I'm forced to follow them. So let us begin. I am not going to get out algebra tiles. I refuse. However, we are going to use them. They are very simple to use. In algebra tiles, there's a little tiny square and a little tiny shaded in square. That is 1. That is -1. Put them together and you have 0. Okay? Now, if I line 5 of these up, what number does that represent? 5, because you can all count. Excellent. Now, the next that covers what part of polynomials? Coefficients, variables, or constants? Constants, because it's 1. Or if there's 2 of them, it's 2. If there's 3 of them, it's 3. That's a constant. So we still need to cover our variables, right? A variable is a bar of indeterminate length. It's about 4.8 of these, but you can't tell exactly. And when you can't tell a number exactly in math, what do you give it? A letter. So that is a variable. It's an X or a Y or a Q or a Z, whatever. Obviously, that is a negative X or Y or Q or a Z. Put them together, you get 0. And lastly, and this is why I do not like algebra tiles, because they are only remotely useful to a maximum degree of 2. Because this is X, and this is X. If those are the same length, what's that? X squared. And then what is that one? Negative X squared. And if I put them together, what do I get? 0. Okay? Now, algebra tiles do have some use. They're actually the only way to show kids and make them understand why subtracting a negative is the same as adding. That's about the only use I have found for them. But we're going to spend some time with them anyway. So I have been given this monomial, and I'm multiplying it by this binomial, yes? If you were going to say this in English, what would you say? 5 times x plus 1, right? Which means if I drew x plus 1, x plus 1, how many times would I need to draw it? 5 times. Agreed? Okay. That makes a rectangle. Right? This is the product. Up here are the sides of the rectangle, right? Which means there's the length and width, yes? Which makes these sides the factors. And all you do is look what's on the side. How long is this? X. How long is this? 1. 1, 2, 3, 4, 5. I've lined up 5 little dots, boxes, so this side is how long? 5. 5 times x plus 1. That looks like an 8. 5 times x plus 1 equals what's inside there? 5 x's plus 5 boxes. Right? And that is the third thing I'm supposed to teach you. And this, of course, you also already know. 5x plus 1 equals 5x plus 5. We just proved that. What did we do? We did 5 times x, and then we did plus 5 times 1 to get 5 times x, 5x, plus 5 times 1, 5. And this is the distributive property. Many teachers give it fun, cute little names. I do not, because it is the distributive property. Okay? I don't care what your previous teachers have called it. I'm sure they all have fun little names for it. I do not care. Just like I do not call Jessica Kaboobly Hines. I call her Jessica, because that's her name. The distributive property is very easy. A, B plus C equals A times B plus A times C. Now, you are intelligent young people. What if it was A times B plus C plus D? What would it be? AB plus AC plus AD. Easy peasy lemon squeezy. Yes? Now, when you are doing the distributive property, can you forget all your other math? No. All other math applies. So, what do I mean by that? Show me a picture. Picture is tiles, what we just drew. Algebra is the distributive property. So, are these right here factors or a product? They're factors. How do you know they're factors? Because x is multiplying by 2x minus 4. How many factors are there? This is a slightly trickier. 2. What are they? X and? No. 2x minus 4 is the other factor because it's in brackets. So it's all one thing. Everybody good? Now, if I'm doing a picture, where do the factors live? In the middle or on the sides? On the sides. How would I draw x? A bar. How would I draw 2x minus 4? X, 2x, and 1, 2, 3, 4. What do I need to do to those 4 little guys? Shade them in because they're negative. Now, there's x, yes? But that x is what? Been stretched that far to make what? X squared. Same thing happens here. X squared. Now, this x keeps its length and keeps its width. But what wins? Negative or positive? Negative. And what is the answer? The answer, or the product, lives inside the rectangle. And what is it? 2x squared minus 4x. And of course, with the distributive property, I distribute. I know it's blue. And I get x times 2x minus x times 4. X times 2x, all other exponent laws apply. So x times x is x squared 2x squared minus 4x. Hazel. Of course. Gouda? Great. You do the next one. Draw it and give me an algebra solution. I'm about to talk about that. No, and I'm about to talk about that. When I ask you to do it yourself, and I write mine up, some of you put your 3 x's vertically, and you put your x plus 2 horizontally. Does it matter? No, why? What is 5 times 2? What is 2 times 5? It does not matter because multiplication is what we call commutative. Order doesn't matter. Same with addition, because multiplication and addition are related, aren't they? Actually, multiplication is a shortcut to repeated addition. It doesn't actually exist. We invented multiplying so we didn't have to say 4 plus 4 plus 4 plus 4 plus 4 plus 4. We could say 4 times 6. Okay? What do I mean by commutative? Being the same as addition. What's 4 plus 6? What's 6 plus 4? Commutative. Everybody good? All right. Now, being the intelligent young people that you are, how many factors are there? 2. Factor 1, factor 2. Where do factors live in the rectangle? Outside. Factor 1, x plus 3. Factor 2, x plus 2. Fill it in. Now you will notice I'm not being very careful with my drawing, yes? I mean, these are not perfect little rectangles. Do yours have to be? No, of course not. I had a student about 5 years ago. We were doing this unit, and he was like hours behind everybody on everybody's test. And I couldn't figure it out because he was super smart. It's like, why are you taking an hour and a half to do one factoring or one algebra tile question? And I walked back and I watched him. He had a ruler out. And he was measuring. And every box, every squared had to be 2 by 2. Every x had to be 1 by 2. And every constant had to be 1 by 1. And that dude drew them with a ruler. I don't think he brought out a protractor to make sure these were exactly 90, but he may have. You don't need to do that. Okay? What is the answer? Easy peasy lemon squeezy, yes? Now, algebraically, now, if there was no 3 there, what would you do with that? X times x plus 2 times x. Agreed? Okay. If there was no x there, what would you do with that? 3x plus 3 times 2, right? Okay. How would we really write this? How do I really write that? X squared plus 2x, 3x plus 6, yes? What do you notice there and there? They're like terms. X squared plus nothing is what? X squared. 2 plus 3 is what? 0 plus 6 is what? And there's your answer. Now, all of your grade 9 teachers showed you FOIL. I don't like it. I hate it. Because it screws you people up. Because you people, for the most part, are real happy doing this. Binomial times binomial. Easy peasy lemon squeezy. However, in the real world, do polynomials end at binomials? No. So this screws you up. I have it here because you have all seen it before. You know that it stands for first, outside, inside, last. Which is wonderful if there's only 4 terms. I prefer to say what it really is. Double distribution. If you're doing FOIL, first things you see. Outside, the outside pair. Inside, the inside pair. Last. I don't like it because here's why. What if you're faced now, in reality, what is really happening in FOIL? You take the first and you distribute it twice, and then you take the second and you distribute it twice. So what would I do here? I would take the first and distribute it how many times? Thrice. Then I would take the middle one and distribute it how many times? Thrice. Then I would take the last one and distribute it how many times? Thrice. So that's why I don't like the acronym. If you like the acronym, use the acronym. I don't care. Algebra here. Double distribution. Take the first one, distribute it twice. What do I get? X squared plus 4x. Take the second one, distribute it twice. What do I get? Minus 1x minus 4. Please notice when you stack them, it's easy to keep your like terms together. Most of you are taught to write it all horizontally, which is a real pain when you got to do that one. But if you stack them, you can't do it wrong. X squared plus nothing, x squared. 4 minus 1, 3x. 0 minus 4, negative 4. Easy peasy lemon squeezy, yeah? Okay. Do page 111, 112, 113. No, that's where we stop. 111 to 114. Oh, wait.
To 113.
To 113.
Okay.
Yeah, because 114 should say real number system. Okay. Now, listen, please. Listen, please. All old math rules apply. Do not think when you look at something that there's a few on here that are there on purpose to make you say, well, I know what to do, and just, okay? Think. Everybody good? Go.
No, I don't think I'm doing it right. It's not right. Okay.
Oh, I missed the... I missed an X.
Wait. What? Oh no. Yeah, because the 18 is low. I was because it was negative 4 times positive 4, and the negative always like wins or whatever.
There are the answers. If you don't have what I have, ask now. Of course, because all of you for B have x squared plus 4. Because you distributed that 2 in. What's the base there? X plus 2, because it's in brackets. So it's x plus 2, and it's squared. So how many bases do I need? 2. Then I must doubly distribute. That is why I made a big deal out of saying every previous math rule still stands. X squared means x times x, because the base of x is multiplied twice. That's the base, so it's multiplied twice. If it was 2x squared, then it would be 4x squared, because there's no addition. D? Okay. X squared minus 7x plus 9x minus 63. Negative 7 plus 9 is positive 2. No, x times negative 7 is negative 7x. That's a 2. My 7s have crosses. Everybody good? Carry on then. Yep. Any questions? Remember, most of you probably wrote 2A that way. Some people would say you should change the order to that. I don't care. Good? Did people finish 113? Okay, that's your homework for the weekend. I won't put up cumulative marks until Sunday night so you don't get in any trouble.
I just had a question about this one question here, K, on 113. I finished it, but I just want to know the answer.
So that's 2, oh. That.
Okay, I think I know what I did wrong. Because I was talking with Arsh and he got something different, but it's just because I went here with the 5, so I went 5. It would have been positive 25 and that again.
Yeah, but you can't do that because you have to do distribution because there's 2 terms, right?
Yeah.
So I distributed here first, 4x squared minus 10x minus 20 plus 25. And then I got to distribute thrice. Okay? Now, Diana and her sailing regatta. You pretty much screwed up the cake question, though.
Wait, I screwed it. Oh, why? What? Was it 18 to 2?
1,822 inches squared, but the can of frosting does centimeters. So you had to convert the inches to centimeters.
Yeah, but then... When
So you do 1822 times 2.54 squared.
Oh, no. So how many cans was it?
48.
48 cans of frosting?
Yes.
Here, the cans like this?
No.
The cake is not that big.
The cake is huge. A 14-inch cake, that wide, that tall. And then another one.
Yeah, but 48 cans of frosting?
That's a lot of cans.
Whether it's real life or not, it's very high-end frosting. It's made with real gold.
Yeah, that's
That's what, yeah.
yeah.
Like those donuts that cost $5,000. Have a good day. Have a good weekend. See you later.
See you, alligator.
After a while, crocodile. Hannah, I like your shoes. Well, the color. I mean, they wouldn't look good on my feet, but I like the color. Bye.